Then take one.
So you go to, I think it was South Kensington, yes?
I went to see Dr. Griffiths and another scientist at South Kensington, explained the idea. It was very coolly received. Griffiths seized on a mistake I'd made in my calculations. I don't know how it came about, because it was important, but I hadn't made it previously, but somehow or other I'd slipped. But fortunately, when I went back and took another look at the whole thing, I found I'd made another mistake too, which happily cancelled out the first one. Griffith was working, as I now know, on gas turbines, but I had no suggestion of it at the time, except that I was shown a paper that he'd written about compressor blade design, and that was the only suggestion I had that he was working on it.
Of course, at this time, they were moving on now from that. At this time, there were fairly formidable objections to what you were trying to do. Can you summarise them?
The big difficulty I was having with the ministry, really, and when I say the ministry, I would like it clear that it's not the uniform side I'm talking about. I had a lot of help from the uniform side. It's the civilian, the technical civil engineering civil servants who gave me all the trouble. A report had been written in 1920 by a man named Stern about the possibilities of gas turbine, and he'd come to some rather extraordinary conclusions, in my opinion, that it would weigh about 10 pounds per horsepower. A gas turbine driving a propeller was what he was after. 10 pounds weight per horsepower, as against the then piston engine 2 pounds per horsepower. And he said the fuel consumption would be about 1.5 pounds per horsepower hour. That's about 3 times at least what the piston engine could do. And so he condemned it right, left and centre. Other people had been trying to make gas turbines, and they'd run up against the fact that if they had an inefficient compressor, that required a lot more power than theoretically would be necessary. If they had an inefficient turbine driving that compressor, and that was very down on power, so that the net margin between the positive power of the turbine and the negative power of the compressor was so small, in fact, or it could be zero, so that it wouldn't even turn itself over.
So you were really dealing with very narrow margin?
Yes, according to the theories of the time. There was this fundamental difficulty with gas turbines: inefficient compressors, inefficient turbines, and the other big snag was materials which wouldn't stand temperatures of more than, say, about 500 degrees centigrade at high stress.
Whereas you required?
We required to be able to run at over 500 anyway, with stresses of the order of 14 or 15 tons a square inch at the blade root, which was too much. See, the material just wouldn't stand that. The materials then existing in 1929. But I knew, or felt pretty confident, that they would evolve in the normal course of development, and of course they did.
That was what led you to believe that you could lick the compressor combustion and turbine blade problems?
From the start, I was confident that the real answer lay in improving the efficiency of the compressor, and I thought I could do it. Very conceited I was. And that I could improve the efficiency of a turbine. And I did recognise that a very big factor in favour of a jet engine was that when you went up high, the air temperature was very low, very cold, and that benefited the compressor a lot. It meant that you could get much better conditions for the compressor. And being a jet engine, only part of the expansion took place in the turbine, so only part of it was subject to whatever inefficiency the turbine had. And the other thing is that in a normal turbine, the velocity coming out of it is wasted. In the case of the jet engine, that was completely used. So there were several factors in favour of a turbine operating at great height.
Nonetheless, you had to go back to your squadron somewhat disappointed, presumably.
I went back from the Air Ministry after it had been turned down, more or less, and then received an official letter saying that the Air Ministry was not interested. And but nevertheless, W.E.P. Johnson, having had experience as a patent agent, he helped me draft a patent. So I filed a patent in 1930, and the patent was granted in 1932.
Do you think age and inexperience also told against you at that time? You were not a qualified engineer, of course.
It didn't help that I hadn't then received an engineering degree. I just had the experience as an apprentice and experience as a cadet. I had had quite a lot of technical training, but I still had my engineering course and Cambridge course in the future.
Fine, and now we're going to come to that. That's excellent. So what happened next? You go to Henlow. How did Henlow arise? And then perhaps you can take us on to Cambridge in the same sequence.
Right. After I completed the flying instructor's course, I very nearly got posted to number 4 FTS, Abu Sweir in Egypt. That would have been a real nail in the coffin of the jet engine if that had happened. But Group Captain Baldwin again came to my help and had my posting changed. So I sent to number 2 FTS in Digby, where I did a year as a flying instructor. And during that year, W.E.P. Johnson and I made many efforts to get firms interested, with no luck.
Now, at this point in your career, you were expected by the RAF to specialise.
After 4 years, every general duties officer had to specialise. He was given a choice between engineering, radio, navigation, physical training, and so on. But I didn't get a choice because, having been pestering the Air Ministry with inventions, they just said to me, "You will be an engineer." So I was sent to the Officers' School of Engineering at Henlow. And after 18 months there, after the first year, I was put into the second year for lectures. So I really finished the course in 18 months, but made up 6 months in charge of the engine test benches because they had decided, because of the excellent results I got, distinction in every subject except mechanical engineering, that they'd make an exception. The air member for personnel was the angel responsible for that, and they decided that though they'd stopped sending officers to Cambridge, that I would go to become what they called an E-star, which meant an engineering officer with a university degree. So I went to Cambridge in September 1934 to take the mechanical sciences tripos. And we're being already fairly qualified. We were allowed to do that in 2 years. My time at Henlow on engineering was quite effortless, you see, because I'd already had so much training at Cranwell and as an apprentice and as a cadet. And incidentally, this is a point I like to stress, that I owe a great deal to the extensive training I received from the Royal Air Force.
You, during the time you were at Henlow and at Cambridge, did you have time to refine your ideas over the jet?
While I was at Henlow and Cambridge, of course, I was learning more and more about thermodynamics and aeronautics and so forth, and polishing my ideas on the jet engine and convincing myself more and more that it was a good idea. Except at Cambridge, I began to have doubts. I thought, is it, when you learn more, you become more aware of the difficulties. But fortunately, I didn't allow them to daunt me at that time.
Although it took a visit, I think, from 2 colleagues, which you can tell me about now, it took a visit from 2 colleagues to really re-stir the whole thing.
Dudley Williams, an old colleague of mine, we had in fact been cadets together, we'd been together at Felixstowe, and then after being retired for ill health, he joined up with another officer, ex-RAF officer who'd been invalided out after a crash, and they approached me with the idea of forming a company and getting on with it, and they succeeded. They managed to find a firm of investment bankers called O.T. Falcon Partners, and all this was happening while I was still doing the tripos at Cambridge, and Falcon Partners agreed to put up some money, and eventually, in March 1936, they formed the company called Power Jets Limited. When I was approached by Williams and Tinling to do something about it, I had got the feeling, rather, that I might be ahead of my time. With the extra knowledge I gained at Cambridge, I did become rather more aware of the difficulties. But nevertheless, my feeling was, well, if we try, something is bound to come out of it. And it was on that basis that I agreed to go ahead with them.
The critical time with your relationship with Falk must have come when you got when they commissioned, was it they who commissioned Bramson? Can we go through that?
Falcon Partners were approached by an intermediary, an engineer named Bramson. Williams and Tinling got in touch with him, and he got in touch with Falcon Partners. And Falcon Partners commissioned him to write a report on the whole project, which he did, and it was wholly favourable. Bramson's report, you might say, was another of the big key points in the whole story.
What was he? Can you tell me something about him? And his Christian name as well.
His full name, Bramson's full name was Mogens Louis Bramson. He was of Danish origin, but he was a naturalised British subject, and he'd been very much involved with aviation, skywriting and all that sort of thing. He was a qualified pilot, and he was a pretty skillful aeronautical engineer. So his opinion did count for something. And his report, which I think is a classic, inspired Falcon Partners to go on with the job. And so a company called Power Jets Limited was formed with a capital of £20,000, of which £2,000 was put up. It was on £2,000 we started.
Fine. Did you know that M.L. Bramson's letter, which you say in your book you can't trace, is in fact in the Public Record Office together with his report? It's extant, yes. We'll send you a copy of that if we can dig it out. Will you remember that? No? Thanks. If you'd like a copy of it, I presume you would for your record.
Oh, yes, I
yes,
would.
Good. Right. And also at that time, I think perhaps we should say about a word about Lance White, shouldn't we?
Mm-hmm. Falcon Partners was quite a small commercial banking firm, and the principal man who dealt with me was Lance White, who had been trained as a physicist. He was a physicist who became a banker. So to that extent, he knew quite a lot about the sort of thing I was talking about. And I've since heard he was rather impressed by my attitude and outlook on the job when I said to him, look, if you're going to raise money for this thing, do it on the basis that it's a 30-1 against chance.
30-1 against chance.
30-1.
Against chance. Good. Now, going on a little, the birth of Power Jets coincides with your taking your first, isn't it? Can you tell me about the circumstances of that?
Our dealings with Falcon Partners took place at the end of 1935 and the beginning of 1936, and I was due to take my tripos in May of 1936, and I very much wanted first-class honours, so I had to work like hell because I was designing the jet engine and preparing for my finals at the same time. And that was a very difficult thing to do. I had to lay off, stop for about 4 weeks dead, and leave Bramson to do the technical look after the technical side of things while I got on with my tripos studies.
Nonetheless, you got a first.
I succeeded in getting my first, happily, and then was able to turn back to the jet engine. Though, of course, normally I would have been sent back to a squadron somewhere or a maintenance base. But happily, my tutor at Peterhouse was another convert, and he managed to persuade the director of education at the Air Ministry that to give me a chance to go on with the job, and he in turn persuaded Air Marshal Bogle again, Air Member of Personnel, and he agreed that I should stay on at Cambridge, nominally doing a postgraduate course. But a letter I had shows that they knew what was really behind it, because it said, this may mean you'll have to give an increased share of your to the ministry.
Sorry, this meant they had stipulated no more than 6 hours of work a week, hadn't they?
That's right, yes.
So can you tell me how that came about?
When PowerJets was formed, it was subject to what was known as a four-party agreement, in which the Air Ministry was a party. Williams, Tindling and I were joint as shareholders and so forth. And one of the stipulations in this agreement was that I would be allowed to spend 6 hours a week on the job.
How did it come to pass that was, as it were, ignored?
That 6 hours a week specification, as it were, was not other than a paper requirement, I don't think. I certainly ignored it, and no one pulled me up for doing so.
Okay. Right, Sir Frank, the Air Ministry stipulated 6 hours a week, but that got forgotten, I think.
When the four-party agreement was signed, of which the Air Ministry was a major party, the one clause said that I was not to work more than 6 hours a week on the job. But of course, that didn't operate as an effective control on me. I worked practically full time on it, apart from doing a certain amount of wind tunnel research for Melville Jones.
The stipulation presumably was there because they regarded you as a full-serving officer.
I don't know why they specified 6 hours a week. I was, of course, flight lieutenant on specialised in engineering. I now had what was called an E-Star qualification, but there was no attempt to enforce the 6 hours.
One of the things I'm not clear about, and I don't think it's altogether clear in the book, is that you get your first, that's fine. The company is set up, that's fine. And then there's a period in which you suddenly materialise at British Thomson Houston. Can you tell me how all that came about?
Before, when Falcon Partners decided to form PowerJets with the initial £2,000, before the actual company was formed in March 1936, they placed an order with the British Thomson Houston Company, on my recommendation, for the drawings, just for drawings. And then after the company was formed, they placed a contract for the making of the engine. And at that time, all we had was £2,000 of the kitty.
Who is they? The people who placed the order were... Okay.
Falcon Partners placed the order before PowerJets was formed for drawings. And then after PowerJets was formed, PowerJets was enabled to follow up the order for drawings with an order for manufacture.
PowerJets at that time consisted of who?
PowerJets was nothing more than its board of directors. And that was Williams and Tindling, White, Bramson, Sir Maurice Bonham Carter, and I was attached as a nominal chief engineer.
And at that time, operationally, the company was you and what, a room in BTH?
Yes. I was the only effective member of the company, and cooperating with the BTH very closely, I was living at Cambridge initially and just travelling backwards and forwards, staying at the Grand Hotel in Rugby, so forth. And the BTH were pretty good in that they allowed me to use an office actually in the plant, as though I were almost a member of the company.
Or did you in fact build the engine yourself?
Oh no, the BTH built the engine, and I stood over it more or less while it was going on. I stood over the draftsman. I did some of the drawing myself, and the draftsman followed my instructions. And one of the requirements was that every drawing had to be initialed by me.
And at that time, were you feeling fairly confident in your approach to the first run?
I felt that we were going to be all right as far as the simple centrifugal compressor was concerned. I felt that the turbine was going to be all right, but I was uneasy about the combustion problem because we were aiming at 24 times the kind of combustion intensity that was obtainable in those days. So to try and deal with that situation, I went to the British Industries Fair at Birmingham, talked to Babcocks and Wilcox and this firm and that firm, and they all said, oh no, that's beyond possibility, until I tackled a firm called Laidlaw Drew & Company, a Scottish firm. And Laidlaw thought that he could deal with the situation. So he then, under contract from Powerjets, helped me to do combustion tests outside the BTH factory. And we thought we'd solve the problem, but it was another 3 years before we really did. We started to build the engine in 1936, and it was nearly ready for running in March. We had a little trouble there. We had to abandon our starter motor, which was a two-stroke, a post-cylinder Sprite aero engine. Its torque fluctuations were too violent for the shaft, so we had to substitute a heavy electric motor, 20 kilowatt electric motor, for starting purposes. And this was mounted on a four-wheel truck, quite a small truck, complete with the engine. The whole outfit was just on this truck, which was hooked to the factory wall by a spring balance to measure the thrust, we hoped. But when we had to substitute the electric motor for the original starter motor, it was so heavy that it was too much for the tyres. We had to take the wheels off, so we never really got thrust measurements in those early days. But the engine became ready for running proper on April the 12th of 1937. A lot of people said it wouldn't even turn itself over. And I didn't really have that doubt myself, but anyway, what did happen proved the very opposite, because the starting sequence was this. I gave a signal to light up when I turned on a control for a small pilot jet in the combustion chamber. Then I got a signal, thumb up sign from a test fitter who was looking through a little quartz window into the combustion chamber to show that it had lit up. And I was on the main control. Then I gave a signal with my hands to raise the speed with the electric motor to 2,000 RPM, and that was done. And then I opened the main control, and it started all right. It went off out of control, accelerated out of control, and so did everyone standing around it. They all went down the factory like the wind. I didn't, because I was petrified with fright. I just couldn't move. And I screwed down the control immediately as the speed went whistling up and the noise like an air raid siren and so forth. And it still went on accelerating after I'd shut off the control valve. It seemed like perpetual motion, but of course it wasn't. The fact was that a pool of fuel had accumulated in the combustion chamber, which we didn't know about, and that was keeping it running after I'd switched off the control. Well, that sort of thing happened day after day. We had about 4 of that kind of runaway.
Very good. What did you conceive that you were doing at that time? Accumulating data, refining the engine, both, or what was the sort of program that you had in mind?
We had built the engine because it was the only way of dealing with the job with the money we had. We thought, well, the proper scientific way to go about the job would be to build a compressor and test it, build a turbine and test it, build combustion chambers and test it, and then put them all together when the results from each were satisfactory. But the cost for that would have been about £30,000, and there was no hope of getting that amount of money. So the only thing to do was go ahead with the complete engine. In fact, what we were doing was trying to prove the engine right from the word go.
In fact, you were trying to prove the engine from the word go, but you were doing it through 37, 38, 39 against a constant background of financial shortage. There were several things which hampered progress, and I think that in 1937-38, the worst was the tight financial situation. Our financial backers began to get cold feet. They had, quite unrealistically, expected that within a matter of a month or two, we would have an engine capable of flying in the stratosphere.
Here it is. In the precise language of the engineer, it's called a jet propulsion gas turbine. To you and me, it's the jet engine, one of the marvels of this century of marvels. When they start it up, stand back. Its deep-throated voice will climb to the shrieking of 1,000 fiends. Its flaming breath is white-hot gas, fed by drafts of liquid fuel. Watch that gallon go. And all around, the straining fury of its power sets the very air a-shudder. Here is the inside story. Air and fuel ignited in combustion chambers, and the resulting gas ejected through a jet pipe at the rear. Now, in the path of the rushing gas, insert a bladed wheel, a turbine. Link the turbine to a powerful fan, so placed as to ram the air into the combustion chambers under pressure. Let the gas drive the turbine and the fan. Under fierce compression, the temperature rises, and the expanding gas roars from the jet pipe with tremendous force. This is the turbine jet, the power that is driving the fighters of today through the sonic barrier. Now, on the forward end of the shafting system, mount an air screw. Here is another new means of propulsion, the turbine propeller, the engine that is opening fresh vistas of simplicity, efficiency, speed. To the British aircraft industry, the turbine jet and the turbine propeller engines have brought a golden opportunity. Says the Dean of British Air Designers, Charles Clement Walker,
"In this new form of air travel, Britain has the chance to make up the leeway lost in the war, when we were developing combat aircraft to the exclusion of all else."
In many a research center, they are grappling with the special problems posed by the enormous power of the jet. And as Britain's new prototypes take shape, planes which many believe will give her a leading edge in the competition of the sky, a glimpse of the future they are heralding is given by the well-known airline executive, Peter Masefield.
At a speed of 2,000 miles an hour, which is at least in sight, the journey from London to New York could be completed non-stop in about 2 hours. And of course, New York time is 5 hours back on London time. Passengers could leave London after lunch, say at 2 o'clock in the afternoon, and arrive in New York for an 11 o'clock coach the same morning. So as far as the clock goes, they would arrive 3 hours before they started.
No wonder that amid such promise of adventure, the rising generation should desert all loyalties to the footplate and the fire brigade, should crane its neck skyward to the streaking silver that bespeaks tomorrow.
Nice to meet you. Look, and I ain't only 52. That's how I run. Why is he flying though? Gosh, what? It's upside down. A Hawker N746. That's Vampire.
No wonder, too, that the airy whistle of the jet should have brought a mysterious jargon all its own to the language of the engineer.
Well, with the tubular type heat exchanger, to get the air you want a lot of tubes, and consequently the inside diameter of the tubes are very small. Consequently, the overall power output will go down, just like this.
It began in the year 1926. Remember 1926, when the symbol of Great Britain was a famous bowler hat, when America stood silent at Valentino's grave, when Suzanne Longlong was queen of the centre court at Wimbledon, when Donahue was booting home the winners. In that year, at the Royal Air Force College at Cranwell, there was a young cadet who had been interested in aircraft since the tender age of 3. His name, Frank Whittle. Now in his 19th year, Cadet Whittle wrote a thesis. His idea was not new. 2,000 years ago, Hero of Alexandria had thought of it. Later, in the pages of history, Newton had given it his passing attention. But Whittle believed that this idea could fly. It was fortunate indeed that Whittle's notions should gain the sympathetic ear of his instructor, Flight Lieutenant Patrick Johnson. Doubly fortunate that Johnson happened to be well acquainted with the world of patents.
That's right.
Well, come and tell me about it.
Have you got time now? Yes, fine. Well, look. This represents a centrifugal type compressor, like an enlarged supercharger. I use this to pull in air at the front and to compress it into combustion chambers, like this, where the injection and burning of fuel heats and expands the air and gives it enough energy to drive a turbine, which drives the compressor, after which the air still has enough energy to give a high-velocity propelling jet. Have you ever patented anything? No, I don't know a thing about it. Does a patent both publish and protect? That is the whole point of patents. But one thing's essential. File a patent application before touting the thing round, otherwise you haven't a hope. I'll tell you what, let's rough out a specification now. Fine, what do we do? Well, you make a rather better sketch, and I'll get on with the clever bit, the writing. Okay.
And so, with the specifications of an idea tucked under his arm, Johnson walked through London's stately Inns of Court to the patent office. On his way, he glanced into the library. that famous library where the walls are lined with dreams. Illustrious, unknown, crazy. Would this dream fade forgotten too? Or might it usher in a revolution in technology? In the county of Leicestershire stands the town of Lutterworth. Here John Wycliffe was born. From here Thomas Cook organized his first tour. And here too, in a disused foundry, a little company set out to bring the idea of the jet to roaring life. Here, Whittle and his associates started up the age of the gas turbine, and in so doing, embarked on the inventor's long road of discouragement and danger. England heard little of all this, but what it heard convinced it that this idea could only fly in the face of all experience.
Have you heard the latest crazy idea about aero engines? Some Air Force chap, Whittle I think his name is, or something like that.
Yes, something about using gas 500 or 600 degrees temperature.
Nothing could take a temperature like that. Why, the whole thing would explode in his face.
But across the fields of Leicestershire, where Squire Osbaldeston once ran his 30 miles a day, and Nimrod talked horses all night as the pot went round, a new music began to mingle with the sound of hoop and horn. The whining cry of a gas turbine, running sweet and true. But as yet, only for a moment. Time and time again, they saw the instant of success dissolve once more into weary hours of failure.
I'm sorry to say we've had another blade failure. We were running at nearly full speed, and one of the blades came off. If we could only get another 50 degrees centigrade, it will do the trick. Yes, please do. I'm sure we're almost there.
They were almost there. And in the final months of World War II, the idea was not only aloft, but on active service. And as the British meteors tore into the flying bombs, jet met jet in combat. In a few short years, the gas turbine has burnt its fiery mark into the calculations of engineers and economists alike. Yesterday, a hope in the minds of a dogged few. Today, manpower and money on a national scale are flowing into its development. For in this latest wonder of applied science, Britain sees a source of her future wealth and welfare. To the birthplace of the jet are coming students from all the world to take their first peep at this child of Britain's brains. But most vital to a people whose memorials of the poignant past daily remind them of the stark needs of the present is the fact that this invention places in their hands an export attractive to nearly every progressive country overseas. In the factories whose devoted labor sustained the fighter pilots through the days of peril, skills famous the world over are now working to capacity on foreign orders for a new prime mover, at once cheap, efficient, simple. And in the heart of London, the company which pioneered the jet now adds to Britain's earnings of foreign currency by the sale of licenses abroad.
We're prepared to grant your company a license under these patents and an option under the other 300 or so which apply to gas turbines in general, on the terms I gave you yesterday.
Meanwhile, screaming from the rooftops to the stratosphere, the jet is opening realms of height and speed hitherto unknown to British test pilots, like John Cunningham and John Derry.
The greatest height we've been to so far has been 59,446 feet. That is nearly 12 miles high and about double the height of Everest. We have exceeded the speed of sound in the DH-108, in which we've done most of the work. And contrary to opinion, this has no physical effect on the human body.
History, they say, is but a series of exploded ideas. Each day, each hour, the jet propulsion gas turbine is making history before our eyes, piling record upon record-breaking record, shattering the accepted ideas and limits of the piston engine age. But today, British engineers are foretelling as great a future for this marvel on the ground as in the air. In workshops which were known to Watt and Stephenson, they are now forging a second industrial revolution based on the gas turbine. Soon, a cracked British Railways Express will be gas turbine hauled, says Chief Engineer Hawksworth of the Western Region.
2 locomotives powered by gas turbines are at present under construction for the Western region of the British Railways. We hope to use them to haul the famous Cornish Riviera Express, and we believe they will be capable of very high average speeds.
From other furnaces are coming the special secret formula metals to start the new power source on its career at sea. Soon, one of Britain's largest tankers will be equipped with a marine gas turbine engine, designed to give maximum performance on the cheapest of fuels.
I've just had a communication from the company in which they say that our gas turbine is nearly ready.
We're all ready to accommodate it and test it out under sea-going conditions.
But Captain McDougall will not be the first skipper to sail under gas, for already under trial is the first gas turbine warship, His Majesty's experimental gunboat number 2009. By land and sea and air, the story is the same. From Britain's laboratories and factories and airfields, the whistle of the jet is spreading all around the globe, a contribution of dimensions yet unfathomed to mankind's mastery of space and speed and power. Today, the Cranwell cadet of 1926 is Air Commodore Sir Frank Whittle, KBE CB FRAeS. Today, the little company in the disused foundry has given birth to another mighty field of industrial endeavor. And now, behind the lonely pioneers of an idea, there stands the science of 2 continents. Quarter century ago, the jet propulsion gas turbine did not exist. In a quarter century, it has given us a vision of the sounds and shapes of future time. What wonders will the jet have wrought? A quarter century from now.
Thank you.